So if we go ahead and want to fill out an APT file for our example for HD209458B, we'll start a new APT file, we'll put in our proposal information, put in our target information, and then we go over to our observations folder. And first we want to specify our instrument, which in this case is NIRCam, our template, which is the NIRCam Grism time series, and then for the short wavelength channel mode, we want to select Grism. Then we want to go ahead and, as I said before, target acquisition is important. We want to specify our target acquisition parameters. And then once we do that, we're going to go ahead and specify our Grism time series parameters at the bottom. You'll first select your subarray. Reminder that the subarray names are different in the APT compared to the ETC, but they correspond to the 2, 4, or 8 spectra options. And then you want to go ahead and specify your short wavelength filter, your long wavelength filter, and then whatever information that you have for your groups per integration and your number of integrations based on your ETC calculation. Once you do this, you want to go over to the Special Requirements tab and select On Hold and place the observations on hold using this requirement. This is important to do because, as Aaron mentioned earlier, there are these additional readout patterns that will be available for scheduling cycle 4 observations like the DHS 3 through 7, but those readout patterns are not yet available in APT and ETC, so there's nowhere to specify that information. So what we'll want to do is we'll want to estimate what readout pattern might work for our observations and then place our observations on hold and write a little comment here in the special requirement saying that what we estimate the readout pattern to be and the number of groups per integration and the number of integrations that we need, and that those will be updated based on our selected DHS readout pattern. We'll also go ahead and we'll see that in the visit view, we have a data excess error here. We have a data excess of about 34,000 megabytes. And so this data excess indicates that the observations as they are right now with the rapid readout mode and the small number of groups per integration is not able to be scheduled. But if we change the readout pattern, as we mentioned that we would do before scheduling the observations in that on hold comment, it should help and the observations could then be made feasible. So we'll want to put a little note in the observing description section of our APT file specifying this. We'll state what readout pattern we want to use based on the total exposure duration for the observation, based on the excess, data excess constraints, and also the saturation limits. And just as a reminder, the DHS and exposure patterns are not going to be available in time for the cycle 4 submission. So this is the workaround that we have to do to specify what DHS readout patterns we would like to use or that could be feasible. We'll also want to provide an estimate of the data excess that we expect to generate once we update the readout pattern. The way that we do this is we note the data excess that's given on the visit view of our placeholder observation when we use the rapid readout mode. And then we want to use that big table for the different subarrays to multiply the data excess rate for the selected readout pattern, DHSN, and the number of groups that we select, and take the ratio for that data excess rate to the data excess rate for rapid readout mode and 3 groups per integration, again referencing that table on the previous slide. If for some reason you set up observations that are not covered in the cases that are shown on that table, please submit a NIRCam help desk ticket with the subject DHS data excess, and then put the number of that help desk ticket in the text here in the observing description. Just to reiterate again, so the way that we want to estimate the data excess is we want to multiply the data excess that we see in the visit view of our observations in APT, so that's listed here. So in our example for HD209458B, that's our data volume over here. And then we also want to take the ratio of our selected readout pattern. In this case, we select DHS4 for 3 groups per integration, which gives us a data excess rate of 0.99 gigs per hour. and take the ratio of this DHS4 data excess rate to the data excess rate when we use the rapid exposure pattern and 3 groups per integration, which is 7.16 gigabytes per hour. And when we do this calculation, we have an estimate of the data excess of around 4.8 gigabytes for this particular observation. And we see that with this data excess, we are below the 5 gigabyte threshold, and these observations are feasible. Just to recap some of the things that we have presented here, we are planning a calibration program for the short wavelength Grism observations with NIRCam. So while these calibrations are underway, remember that this is a shared risk availability. The mode is still being calibrated, and so your actual observational precisions might differ from the predictions that you get from ETC, but a calibration program specifically for exoplanet transit observations is planned. The proposal ID is listed here, and the goal of this calibration program is to obtain a flat transmission spectrum for a target that is yet to be specified, and do a DHS wavelength and flux calibration, and also perform a DHS science verification. In summary, so short wavelength Grism time series is available for cycle 4. We the spectroscopy, the spectral resolution for the short wavelength time series is between 3 and 600 and provides spectra in various bands between 0.6 and 2.3 microns, simultaneously with long wavelength time series observations. Multi-stripe readout mode enables these observations to be performed. And when designing your short wavelength Grism time series, data access and long wavelength saturation are our primary concerns. So the APT and ETC have been updated to help us prepare some of the short wavelength Grism time series observations, and you can use the workflows that we've outlined here in order to set those up. Pandexo is going to be updated soon to include DHS, so stay tuned for that. And again, this mode is being offered at a shared risk, and if observations are infeasible, they may be unapproved. And calibration efforts for the short wavelength Grism time series are planned and going to be done within the next cycle. So here's some relevant links in JDocs, and with that, I think we'll wrap up.